Hey, let's do some work solving some one-step equations. And we are going to do the opposite of whatever is happening to x to be able to solve this equation. So if x is being added with 12, then we're going to subtract 12. Because really what we want is we want this to go away. So if I have plus 12 and minus 12, that goes away. And all I have left is x. And x is a little bit like your friend that's an introvert, where they just kind of want to be left alone. So you can help out your friend x by getting the 12 to go away. So minus 12 on the left, minus 12 on the right. I have to do it to both sides because equations are a bit like those balance scales that you've seen. They look like this, where if you put one object on one side, you have to put the same object on the other side to keep it in balance. Or, if you take off an object from one side, you have to take off the same object from the other side to keep it balanced. Equations are like that. The sides of the equation are balanced. That means equal. So whenever we start messing around with equations, we have to make sure to do the same thing on both sides. Over here, I subtracted 12. Over there, I subtract 12. And then I wind up with x equals 14. Okay. The cool thing about equations is you can actually check your work and see if you're right. So if I just take my original equation, whatever it was, x plus 12 equals 26, I decided that I think that x is 14 when I solved it. So all I got to do is take my 14 and put it in instead of the x, and then I can just see if it works out, right? So I just rewrote the equation, x plus 12 equals 26, and instead of the x, I put in 14. So now it says 14 plus 12 equals 26. Now, is this part the same as this part? That's the question. Is 14 plus 12 actually equal to 26? And yeah, it is. So 26 equals to 26. So if I wind up putting in the 14 and getting a true statement at the end, then I know that that means that 14 is the correct answer. So there you go. I solved it and I checked it. Number 2, x minus 13 equals 28. So again, take a look. What's happening to the x? We've got a minus 13 right there, so we're going to do the opposite of whatever's happening to the x. So we will add 13 to both sides to keep it in balance. Minus 13 and plus 13 together go away. So that leaves us with x equals 13 plus 28 is going to be 41. Now let's check it and see if we're right. So x minus 13 equals 28 is what it says at first. So if I put in my 41, that's 41 minus 13 equals 28. And then I can, do a bit of subtraction. 41 minus 13, I need to borrow 1. 11 minus 3 is 8. 3, and then boom. So I am correct. 28 on the left and 28 on the right. Okay, number 3. So here we have x being multiplied by 9. It's not being added or subtracted. So I need to think to myself, okay, if I want to make the multiplication go away, what's the opposite of multiplying? Well, opposite of multiplying, the inverse of multiplying is dividing. So I need to divide by 9 instead of multiplying by 9. And when I do 9x divided by 9 like this, I wrote it as a fraction here, which you could write it like this or write it like this, and it's the same thing. But when I do 9x divided by 9, basically I'm just going to divide this 9 with this 9, and it winds up equaling 1. So I wind up with 1x, which is just x. So these two 9s divide out, and I am left with x equaling, I did do 117 divided by 9, don't I? To keep it balanced. 117 divided by 9, so I put the 9 on the outside. 9 goes into 11 one time, and so then I can subtract, and I get 2. I bring down the 7, and 9 goes into 27 3 times, so I get 13 for the answer there. So x is 13. Now, to check my work and make sure that I'm right, because I always want to check my work with equations, because why would I get it wrong if I don't have to? 9 times 13, does that equal 117? So instead of the x, I put the 13. I multiply 9 with 13 to see if it actually makes 117. So let's do a little multiplying here. 13 times 9. 9 times 13 is 27. 9 times 1, I will carry the 2. 9 times 1 is 9, plus 2 is 11, so it's 117, and look, that's exactly what I was supposed to wind up with. So I get 117 on the left and 117 on the right, and boom. done. Number 4, x is being divided by 6. That fraction there, don't get confused by fractions. That fraction means division. So x is being divided by 6. So instead of dividing by 6, I'm going to multiply by 6. So multiply by 6 on both sides. Now, a kind of funny thing happens when you multiply by 6. When you have a fraction like that, you wind up with basically 6x over 6, which is just winds up being x, because the 6's, they can divide out with each other. So we wind up with x equals 14 times 6 times 6 equals 6 times 4 is 24. Carry the 2. 6 times 1 is 6 plus 2 is 8. So x equals 84. And that's that. Now, to check our work here, instead of x, we need to put in 84, because that's what I just found out that x was. So 84 over 6 equals 14. And then, does 84 divided by 6 actually equal 14? Yes, it does. I know this because, take a look. 84 in the house and 6 outside the house. 6 goes into 8 once. Subtract. Bring down the 4. 6 goes into 24 4 times. So yes, this number is 14. So it's 14 equals 14. Check. Moving on, 3/5 x equals 12. Now, this is a hard one. I included this one for the purpose that it has a whole fraction sitting here with x. And people usually get a little freaked out by fractions, but you don't have to freak out. We're going to solve this thing, and we're going to move on. There's a cool fact about fractions that if you have any fraction, let's just pick a random fraction, like a crazy, terrible fraction, like 107 over, 91 or something like that. There's a cool fact that if you take any fraction in the world and you multiply it by the reciprocal of that fraction, the same numbers but in the opposite direction, like one on the top, one on the bottom, you always wind up getting the same answer, and it's 1 every time. It doesn't matter what the fraction is, which is really, really helpful for questions like this one, because if I have a fraction sitting there with x that looks intimidating, but really all I have to do is turn that fraction over, so 5/3 instead of 3/5, and multiply that by whatever is happening to the x. And I do the same thing on the other side, because I have to keep my equation balanced. I have to keep everything equal. So we'll take a look at this, right? 5 times 3 is 15. 3 times 5 is 15, so I get 15 over 15, x, and that equals 12 times 5/3. 12 times 5/3, 12 over 1. 12 times 5 is 60, and 1 times 3 is 3, so 12 times 5/3 is 20. So 15 over 15, x equals 20. But I know that 15 over 15 is really just the number 1. So really, this thing can just kind of go away here. And that leaves me with just my x. So my x here is 20. Now, I can still check my work like I did with everything else here. And I am going to take my original fraction, my original equation, 3/5 x equals 12, and instead of x, I'm going to put in the 20. So 3/5 times 20 equals 12. And then I just do a little bit of fraction multiplication, 3/5 times 20 over 1, and that gives me 60 over 5. And then I just got to think, what's 60 divided by 5? And if you remember your multiplication fact, 60 divided by 5 is 12. So I wind up with 12 over here and 12 over here. So my solution is correct. X is indeed 20. Thanks for watching this video. If you liked it, subscribe, like, get this video out to your friends so that they can get help with math too. Peace. See you later.